All right, guys, I'm going to run you through how to solve some of these tougher equations. So for number 9, an object is dropped. So I'm going to look at that right there. Dropped from rest. Could have just said dropped and left out the from rest, and you would have gotten the same information. If it's dropped, it's under the influence of gravity. And I'm going to write 10 meters per second squared. From rest, that is my VI equals 0 meters per second. And I'm going to alter this just a little bit. When is the speed of the object 9.8 meters per second? I'm going to round off just like I do with G. And I'm going to say VF equals 10 meters per second. And there is one other piece of information here, the 20 meters. And so distance equals 20 meters. Now, usually you get 3 pieces of information, and that's all you need to solve a kinematics problem. And so you're given an extra piece of information here, a distractor, and that distractor is this right here. Because it's not asking how fast it will be going when it falls 20 meters. It's saying when will it be falling at 10 meters per second. And so this is just a distractor. We don't need that. The U, what are we looking for, is when, and that is going to be time. And so as I use my equation here, I'm going to say that VF equals VI plus GT. And as I go to substitute in, I will see that my VI is 0. And so really I have VF equals GT. And then I'm going to manipulate this formula to solve for T. So I would say T is equal to VF divided by G. Okay. When I substitute in, I'm going to have T equals, and my VF was 10 meters per second divided by gravity, which is 10 meters per second squared. And so when I solve this, I'm going to get T equals 1 second, and that is my answer. So then coming over here, it is not going to be going 10 meters per second for the entire first second, nor is it after it had fallen 9.8 meters, nor is it during its entire time of fall. It is at the end of the first second of fall. It accelerated to 10 meters per second. Okay. Then we come to number 11. A soccer ball kicked on a level field has an initial vertical velocity component of 15 meters per second. Assuming the ball lands at the same height from which it was kicked, what is the total time? So, sorry, I'm going to move this here and draw a picture. Soccer ball is kicked, comes up and down. Okay. And then, so what am I given from this? Well, I know that it was kicked at an initial velocity of 15 meters per second. So VI equals 15 meters per second. I know that G, it's going to be under the influence of gravity, is 10 meters per second squared. And then I know when it's here, so there's a couple ways I can approach this one. I know when it's there, its velocity is 0. And then I also know when it's here, it will be traveling at the same speed as it was here. To kind of do it that way gets a little bit confusing. So I'm going to concentrate on this right here, that halfway through, its V here is going to be 0. All right, so I'm actually going to look at it from here, saying it was going 15 meters per second, okay, along this line. I should have done it like this. And when it lands, it will be going at 15 meters per second, okay? We're going to call this our VI, and this is our VF. Now, really, this is its initial velocity going up. We're going to call that positive. This should be negative. So be aware that because I'm calling this a velocity, this is going to be negative 15. And I don't normally do this. Usually I just say gravity is 10. But in this instance, because we're going to be talking about this being negative, I am going to give gravity its direction, meaning it's going to be a negative 10 meters per second squared. If this one's confusing for you, just skip over it, okay? And then the other thing that so this over here, my VF is going to be negative 15 meters per second. Okay, so I have 15, negative 10, and negative 15. My unknown that I'm looking for is my time in the air. And then, so my equation that I'm going to use to solve this one is that VF equals VI plus GT. And I'm going to manipulate this formula to solve for T. When I do that, first I'm going to subtract out the VI, and then I'm going to divide by G. So I'm going to get T equals VF minus VI divided by G. When I substitute in, I'm going to get T equals, well, VF was negative 15, recall, minus V, which is 15, divided by, and now remember I did gravity as negative 10 to show the direction because I had to show direction over here. So I have negative 15 minus 15 is negative 30 divided by negative 10. My negatives will cancel out and I'll get T equals 3 seconds. Okay, so that was a tough one. You had to understand about positive and negative direction. I could have just looked at this and said, this is my initial velocity, this is my final velocity, and called it 15, and done it that way. But I showed you this way, okay? So scrolling down. Okay, number 20. So we have, what is the speed of a 2.5 kilogram mass after it has fallen freely? G equals 10 meters per second squared through a distance of 12 meters. Oh, and it started from rest. Okay. So you have 4 things that you are given. You are only required 3 things for a free fall problem. And you will never see a free fall problem that has M in it. That's added information. When we talk about free fall, we say in the absence of air resistance and mass will not come into play. What is the speed? That is our VF. Our equation we're going to use is VF squared equals VI squared plus 2AD. VF squared equals, that's 0. So it's 2 times the acceleration of gravity, so that's a G, times 10 times the distance of 12. 12 times 10 is 120. 120 times 2 is 240. But that's VF squared. So to get VF, I need to take the square root of 240. And if I take the square root of 240, I get 15.5. Now when I come over here, I don't see 15.5, but that's because I used 10 rather than 9.8. So my closest number to that is right there, 15 meters per second. Okay. And then the last one that I'll go over is number 13. A baseball dropped from the roof, dropped right there. VI equals 0. Gravity equals 10. Takes 3.1 seconds. T equals 3.1 seconds. How tall? Distance equals what? So then my equation is going to be my D equals VIT plus 1/2 GT squared. My initial velocity is 0. That makes that whole term 0. My distance is equal to 1/2 times 10 times the time of 3.1 seconds squared. D equals, if you do this out, where's my 3.1? So 48 meters. Once again, that's using 10 rather than 9.8. So when I come over here, I don't see 48, but 47 is close. Okay, and that's the free fall problems.